Question number 30. AlCl3 exists in crystalline as well as in liquid state. Select the correct statement about AlCl3. This is a fact-based question, students. In the crystalline form of AlCl3, the Al lies in the octahedral hole, so its coordination number is 6. And if you look at the molten form of AlCl3, in molten form of AlCl3 exists as a dimer. So the Al is going to have a coordination number of 4, as can be seen from the dimeric structure. Okay. So out of option C and option D, we have to select option D as correct, whereas option B and option C will be incorrect. Students, for this question, we have to select option A and option D as the correct answer. Let us look at the next section now. So students, in this section, we have 2 paragraphs. The first paragraph has 3 questions, whereas the second paragraph has 2 questions. Each of these questions in the paragraph has 4 options, out of which one or more than one option may be correct. So let's start with question number 31. So in the paragraph given for question number 31 to 33, the examiner has given us 1 mole of a monoatomic ideal gas, which is expanded irreversibly from an initial pressure of 10 atmosphere to a final pressure of 1 atmosphere against a constant external pressure of 1 atmosphere at constant temperature of 300 Kelvin. So the initial state given to us is 300 Kelvin. The pressure at that temperature is 10 atmosphere. Now it is taken against a constant external pressure of 1 atmosphere. The temperature is 300 Kelvin itself. The final pressure of the system becomes 1 atmosphere and the process is irreversible. The pressure external given to us is equal to 1 atmosphere. So the examiner seems to be interested in the total entropy change of the universe. So if we talk about the total entropy change of the universe, delta S total, it can be written as a sum of the delta S of the surrounding plus the delta S of the system. So we can deal with the delta S system first, then we can talk about the delta S of surrounding. So delta S system, entropy is a state function. So delta S system can be directly found out from the formula. So we have NCV ln of T2 by T1 plus NR ln V2 by V1. So the temperature term will be cancelled out. This ratio is equal to 1 as the process is isothermal. So the ln term will be equal to 0. So all that is left here is NR ln V2 by V1. The number of moles of gas given to us is equal to 1. So it will be equal to R ln of V2 by V1. Now we can figure out the value of V2 and V1 from the ideal gas equation. So we can have PV equal to nRT. We can have the first system. So in the first system, the pressure is 10 atmosphere. The volume V is V1. So we have 300 into R. So the value of V1 shall be equal to 30 R. So the volume here, V1 is equal to 30 R. Now in the process, there is isothermal expansion happening. So the product of P into V shall be constant, which gives us a value of V2 equal to 300 R. So we are concerned about the ratio in this case. The ratio comes out to be equal to 10. So the delta S system term will come out to be equal to R ln of 10. So we can have 2.303 into 8.314 in the SI unit, as the examiner seems to be interested in the SI unit itself. So on simplification, this will give us a value approximately equal to 19.13 joules per Kelvin. Now we can talk about the delta S surrounding. So if we talk about the delta S surrounding, so delta S surrounding can be written as Q surrounding by T surrounding. The T surrounding is given to us, it is equal to 300 Kelvin. And the Q surrounding shall be equal to minus of Q system by T surrounding. So if you talk about the Q system now, Q system shall be equal to delta U minus W. So the process given to us is isothermal. Delta U shall be equal to 0. So the Q system will come out to be equal to minus of W. So if we talk about the delta S surrounding now, we can substitute the value of minus of Q system. So that will give us a value of equal to W upon T surrounding. Now we have to talk about the work. The work is obviously irreversible in this case. So we can find out the work and then we can substitute the value of work obtained in this expression to get the value of delta S surrounding. So if you talk about the irreversible work in the system, it shall be equal to minus of P external into delta V. So the P external given to us is equal to 1 atmosphere and the delta V. So it will be equal to V2 minus V1. The value of V2, we had seen that it was 300 R and the value of V1 was 30 R. So it will give us a value of minus of 270 R. So if we put the value 270 into 0.0821 into the conversion factor. So this will give us the value in atmosphere liter, and we have to convert the atmosphere liter into joules. So we have to multiply this by the conversion factor which is given to us in the comprehension, which is equal to 101.3. So this will come out in joules. So this on simplification will give us a value of minus 2245.52 joules. Now if we talk about delta S surrounding now, the value of delta S surrounding shall be equal to W irreversible by T. So W irreversible, we had seen that it was equal to minus of 2245.52, and when it is divided by the temperature, which is 300 Kelvin, it will give us a value of approximately minus 7.48 joule per Kelvin. So we had seen that the delta S system was equal to 19.13 joule per Kelvin. So if we use the delta S surrounding as well as delta S system, now if we talk about the value of the delta S total, the delta S total shall be given by the sum of these two values. So we have 19.13 minus 7.48, which on simplification will give us a value approximately equal to 11.65. So if you look at the options now, we can see that for question number 31, we have to select option C as the correct answer. Let us look at the next question now. Question number 32. In question number 32, the examiner seems to be interested in the irreversible work of the process S. So we had already calculated the irreversible work, students. It had come out to be equal to minus 2245.52. So the work is minus 2245.52 in joules. But the examiner has also given us the value in atmosphere liters, so we have to check that as well. So if you talk about the work done in atmosphere liters, so we have the value of work is equal to 270 R. So we can talk about minus 270 R in atmosphere liter. So we have to put the value of R in terms of atmosphere liters, which will give us a value of 270 into 0.0821 in atmosphere liters. So this on simplification will give us a value equal to minus 22.17 atmosphere liters. So students, for this question, option B is also correct. So we have to select both option A as well as option B as the correct answer in question number 32. Let us look at the next question now. Question number 33. Select the correct statements. So in option A, the examiner says delta H of the process is 0. It is true, students, since delta T is equal to 0, which will imply automatically that delta H is also equal to 0. If we talk about the delta S system of the process, so we'd seen that expansion was taking place in the process isothermally. So the delta S system term has to be positive. If you look at the C statement now, delta S surrounding of process is positive. This statement is incorrect, students. We had just calculated the delta S surrounding, which had a negative value. So this is incorrect. Let us look at D option now. During the expansion, heat is absorbed by the system. We can apply the first law of thermodynamics, which says that Q is equal to delta U minus W. So the delta U term shall be equal to 0. And since work is done by the system, that work will be done by the system when it absorbs heat from the surrounding. So this statement is also correct. So students, for question number 33, we have to select option A, option B, and option D as the correct options. Let us look at the next paragraph. So in the paragraph for question number 34 and 35, we have been said that magnetite is a mixed oxide of iron. It consists of FeO and Fe2O3. Assume that the given sample was lying in contact with oxidizing agent, and hence it contains more Fe2O3 than FeO. So the given sample of magnetite on reaction with carbon monoxide form iron metal and CO2. And if 39.2 gram of the given sample of magnetite on reaction with sufficient carbon monoxide produces 15.60 liter of CO2 gas at STP, then we have to talk about the content of the sample. So let us first try and tabulate the data which is given to us. So we have a sample of magnetite. The mass of magnetite sample given to us is 39.2 grams. So it consists of FeO and Fe2O3. Usually it is a 1:1 mixture, but it is given to us in the comprehension that it was lying in contact with some oxidizing agent. So let us assume that the given sample contains A mole of FeO and it contains B mole of Fe2O3. So we can have equations now. The molar mass of FeO is equal to 72, whereas the molar mass of Fe2O3 is equal to 112 plus 48, which gives us a value of 160. So we have 72 into A plus 160 into B equal to 39.2. So this is the first expression. We can now have the reduction reaction, in which it is said that the given sample was allowed to react with carbon monoxide, which produces iron metal and CO2. So we can have FeO reacting with CO to give us Fe plus CO2, and we can also have Fe2O3 reacting with CO to give us Fe and CO2 again. So the first reaction is balanced. If you look at the second reaction now, the N factor of Fe2O3 is equal to 6, whereas the N factor of CO is equal to 2. So we can have the balancing with the 3. So 3 CO will form 3 CO2, and in order to balance the Fe, we'll have to just add a 2 on the right hand side. So this represents the balanced reaction in the second reaction. Now we had assumed the moles. So the moles of FeO was equal to A, whereas the moles of Fe2O3 was equal to B. So FeO, when allowed to react with CO, it will form A moles of Fe and A moles of CO2 as well. And when Fe2O3 is allowed to react with 3 moles of CO, it is going to form 2B moles of Fe and it is going to form 3B moles of CO2. Now the examiner has also given us the data about the total volume of CO2 produced. So it is given to us that 15.68 liter of CO2 is produced. So if we talk about 15.68 liters at STP, it has to be divided by 22.4. It gives us a value equal to 0.7. So total moles of CO2 is equal to 0.7. So we have the second expression as well, that A plus 3B shall be equal to 0.7. So this is the second reaction. Now if we try and solve this two equations which are formed, we'll have the value of A equal to 0.1 and we'll have the value of B equal to 0.2. So let us look at the options which are given to us. So in the A option, the examiner says that the mass of Fe2O3 in the given sample is 32 grams. So we have 0.2 moles of Fe2O3 and the molar mass of Fe2O3 is 160. So the mass of Fe2O3 in the sample will be equal to 32 grams. So which automatically makes the B statement also correct. Total mass of the sample was 39.2 and the mass of Fe2O3 is 32. So the mass of FeO shall be equal to 7.2. If you look at the option C now, CO2 produced by reaction of Fe2O3 is 4 times the CO2 produced by reduction of FeO in the above given condition. So if we talk about the moles of CO2 formed by reduction of FeO, we have the value as 0.1. And if we talk about the moles of CO2 formed by reduction of Fe2O3, we have the value as 0.6. So the moles of CO2 formed by Fe2O3 is 6 times and not 4 times. So statement C will be incorrect. And if you look at the D option now, on complete reduction of 39.2 gram of the given sample of magnetite with carbon monoxide, 28 gram of iron is produced. So if we talk about the iron now, we have A plus 2B moles of iron. The value of A was 0.1 and the value of B was 0.2. So 2B shall be equal to 0.4. So if we talk about the total moles of iron formed, it shall be equal to 0.5, which means that half mole of iron is formed and the mass of half mole of Fe is indeed equal to 28 grams. So students, the fourth statement is correct. So students, for this question, we have to select option A, option B and option D as the correct answer. Let us look at the next question now. In question number 35, the 39.2 gram given sample, which is given in the paragraph, is completely oxidized to Fe3 plus by KMnO4 and K2Cr2O7 in different experiments. So XML of 0.1 molar KMnO4 was required and YML of 0.1 molar K2Cr2O7 was required. Select the correct statement. So we have a sample of FeO and Fe2O3. So all of the iron is converted into Fe3 plus. So this will not take part in oxidation. Only the FeO shall be oxidized. So we have the N factor of FeO equal to 1 and the moles of FeO present was 0.1. So we can have the gram equivalent concept. So we have 0.1 into the N factor. N factor is equal to 1. This is the gram equivalent. We have to convert it into milliequivalent. So we have to multiply it by 1000. As the data given about the oxidizing agent is in terms of the milliequivalents. So this shall be equal to x into 0.1 into 5, which is the n factor of K-4. And this shall also be equal to y into 0.1 into 6, which is the n factor for K2Cr2O7. So in solving this system of equations, we're going to have the value of x is equal to 200. And if we solve for y, we're going to have the value of y equal to 166.67. So students, for question number 35, we can see that the option A is correct, option B is correct, and option C is also correct. So for question number 35, we have to mark option A, B, and C as the correct answers. Let us look at the next section.